Chapter 5, Lesson 3 of Advanced Algebra, we're going to wrap this up by taking a quadratic that's in standard form and putting it in vertex form. Now, in the last video, we were told what the vertex was, therefore giving us the h and the k, and we were told another point on the graph, either in terms of we had the graph itself, or we were told, giving us an x and a y, which allowed us to calculate the value of a. Well, once it's already in standard form, we're not given that information, so we're going to need a way to calculate it, and so we have to remember what we did in lesson 1. And if you remember what we did in lesson 1, we found the value of the vertex by taking the opposite of b over 2a, which gave us the x value of the vertex. So we're going to use that, and that's going to be my h. And then we found the y value of the vertex by substituting that value into the expression that gave me the y value of the vertex. So that's how I'm going to have to figure out the k here. Now, that still doesn't give me an x and a y to figure out a. So how am I going to figure out a? Well, actually, a in this form is going to be a lot easier because this a here matches the a in standard form. You remember standard form is ax squared plus bx plus c, so the a in standard form is the a that's in vertex form. So the only thing we have to do is go back to lesson 1 where we calculate the x value, giving me the h, we substitute it in, giving me the k, and then the a is simply the a that's in standard form right here. So this is how we were going to have to do this when we're in standard form. A little bit more complicated than if the vertex is just given to us, but nothing that we can't handle anyways. Okay, so what would be the vertex form here? So I need to do the opposite of b over 2a in order to get the x value. So first, we always want to know what our a is. That's the number that's in front. The b here is -4, and the c here is 6. So I have my a, b, and c, so I just simply substitute these values in. So the opposite of b here, which is -4, over 2 times a. So this is a +4 over 2, which is 2. So my h, or my vertex, the x value of my vertex, is 2. Now to find the y value, I substitute it in here. So I have 2 squared minus 4 times 2 plus 6. So this is 4 minus 8 plus 6. So 6 and 4 is 10 minus 8, which is 2. So this is 2. So I have my vertex, which means I have my h and my k, and I have my a already, so I just put it in vertex form. So y equals a, which is 1, and again, I don't need the 1 when it's in vertex form because that 1 can be multiplied out. So as a matter of convention, we don't need to write it. Plus 2, so here's my vertex form given the standard form. All right. Now, one special note, or one final note to remember here as you look at these is when it's in, if there is no linear term, I talked about this earlier, if there is no linear term, it's already in vertex form. Okay, so when it asks you to put this in vertex form, because there's no bx term, it's already in vertex form. Now I'm going to go through that whole process just so you see we end up back where we are, but if you can remember that, then you won't have to do all this. All right, so again, we want to figure out a is -5, b here is 0 because there is no linear term, and c is 12. So I have to do the opposite of b over 2a to get the x value of the vertex. So the opposite of b, and b here is 0 over 2 times -5, so that's 0 over -10, which is 0. So the x value of the vertex is 0. The y value I get by substituting this in and simplifying. So this is going to be 0 squared, which is 0, times -5 is 0 plus 12, which is 12. So my vertex is at 0, 12, and then my a is -5. So if I substitute this in, the a value is -5, x minus 0 squared. Let me get that. Sorry for the interruption. So we have x minus 0, then 12, and then plus the k. Oops, that doesn't look like a plus sign very much, does it? plus 12. And then if we simplify this, we get, well, x minus 0 is x squared, so negative 5x squared plus 12. So you'll see I end up right back where I started. So you can save yourself some time if you recognize that if there is no linear term, the equation is already in vertex form. One more scenario where we're given 2 points that are on the graph of this parabola and we want the equation in vertex form. How do we determine what this is? And this goes back to something we did a couple lessons ago where we simply substitute the x and the y value into each one of these and simplify it as far as I can, and that's going to create a system of equations which I then use substitution in order to determine the a and the k that I'm missing here for my final equation. So let me do an example or two for you. So again, here's a point, an x and a y value, that if I substitute it into this expression, I'm going to get, let's see, a y value of 2 is equal to a, which I don't know, the x value here is negative 3 plus 2 squared plus k. Now if I simplify this as far as I can, negative 3 plus 2 is negative 1 squared is 1, so that's 1a plus k. Here's an equation, 2 variables. I can't solve it. However, if I have another equation, I create a system which I can then use substitution or elimination to figure out the values of a and k. So I use the other ordered pair, substitute it in, and create my second equation. So here y is 11 equals a, which I don't know. The x value is 0 plus 2 squared plus k. And if I simplify this as far as I can, this is going to be 0 plus 2 is 2 squared is 4 times a is 4a plus k. Now if I write that over here, what do I have? But I have a system of equation with the same variables. I can use substitution or elimination to determine the value of a and k. So again, I'm going to use elimination because these are almost opposites, so multiplying everything by a negative sign changes the sign of everything, and then I can add these together. So 9 is equal to 3a, so my a value is 3, and then I can substitute these into any of the expressions to figure out what k is. So I'll put 3 over here, and so this is 11 equals 12 plus k, so k is a negative 1. So I have my a, I have my k, I substitute it into the expression. A is 3, x plus 2, whoops, going too fast for myself here, 2 squared minus 1, so here's the vertex form given 2 points that need to be on the graph. So substitute in each value and create a system, use substitution or elimination to determine the values of a and k. I'll do one more if you'd like to watch it, just so you have another example. If not, you can go ahead and tackle your homework from here. All right, so here are my 2 points. So again, I'm going to substitute those in, create those 2 equations as best I can, or simplify them as far as I can to create those 2 equations. So I have a y value of 6 is equal to a times my corresponding x value of 2 minus 3 squared plus k. Simplifying this as far as I can, this is negative 2 and negative 3, which is negative 5. Negative 5 squared is 25. So this is 25a plus k. Again, 2 variables, can't solve it. Let me rewrite that. I just didn't like how I had that. Now I substitute in the x and y for the other variables, or for the other coordinate, and see what I get. So 1 is equal to 3 minus 3 is 0. 0 squared is 0. Times a is 0. So I have my k is equal to 1. So this simplifies nice. I simply put in my k value over here, and I can figure out a. So this is plus 1. So subtracting over here, so 5 is equal to, that's an a there. Sorry, I forgot to put that in. And then dividing, I get a is 5 over 25, which is 1/5. So I have my a, I have my k, I substitute those in, 1/5, x minus 3 squared plus 1, and I have my vertex form of the parabola that goes through those 2 points.